gone.
The whole thing has gone
The
now?
whole thing is gone. It rolled over about 5 minutes ago.
Where do you want the people evacuated?
Well, we would like to get them off the river in low-lying spots.
It's a calm June morning, and nothing seems out of the ordinary in the towns of Sugar City, Wilford, and Rexburg, Idaho, USA. A few months ago, the Teton Dam was completed, marking one of the greatest engineering feats in U.S. history. The reservoir has started filling, realizing the long-held dream of providing a constant water supply during the summer and controlling spring runoff. This dream was born out of the severe drought in 1961 and the subsequent severe floods. However, on June 5, 1976, this dam turned into a nightmare, bringing death and devastation. How could such an impressive engineering marvel fail so catastrophically? What deadly design flaw went unnoticed, leading to one of the worst disasters in U.S. history? Stick around to discover the shocking details. In 1963, the Bureau of Reclamation proposed the Teton Dam, and Congress swiftly approved it without any opposition. The chosen site for the new dam was almost entirely underlain by basalt and rhyolite, two foundation materials known for their high permeability, making them less than ideal for dam construction. Despite this, the Bureau of Reclamation proceeded with the project. From 1961 to 1970, around 100 core drills were bored at the prospective dam site, revealing the need for further exploration. Leakage tests conducted on the expected right abutment showed no signs of water leaks. However, water levels in nearby holes increased, prompting an examination of the left abutment. This examination revealed several fissures and joints of varying orientations. When the dam's designers received these test results, they largely ignored the identified shortcomings, proceeding with the project as planned. Before construction began in 1971, an environmental impact statement was issued for Teton Dam, but it didn't address the possibility of dam failure. Questions about the EIS, lacking funding, and site preparation work delayed the project. On September 27, 1971, several conservation and environmental organizations filed a lawsuit in Idaho District Court to halt the construction. Despite the legal challenges, Idaho's congressional delegation pressured the Department of the Interior to proceed with taking bids in Idaho Falls on October 29, 1971. In December 1971, the $39 million contract was awarded to Morrison Knudsen Company of Boise and Peter Kiewit Sons Company of Omaha, with construction slated to begin in February 1972. The dam was designed by the Office of Construction at the U.S. Bureau of Reclamation in Denver. It was to be an earthen-type dam, filled using soil from the site. Due to surveys highlighting seepage issues, the designers planned to inject grout into the rock under high pressure to create a grout curtain beneath the core, outside the key trenches and downstream holes or tunnels. The dam's embankment was divided into 5 zones, with the central core being the largest and most time-consuming section to build. The core was composed of a mixture of clay, silt, sand, gravel, and cobbles, carefully compacted by tamping rollers. The Bureau of Reclamation engineers believed this to be impermeable. The completed structure would stand 305 feet above the riverbed. Construction began in February 1972, following a systematic procedure planned by the engineers. The first step was excavating the spillway and key trenches. Early warning signs emerged during the excavation of the main trench at the right end of the dam, where massive open cracks were discovered. Some of these cracks turned out to be caverns, requiring extensive labor to fill with Portland cement. Despite these challenges, the project continued due to the significant resources already invested. In December 1972, while the dam was still under construction, USGS scientist David Schleicher raised concerns about the geological characteristics of the Teton River Canyon. He noted, "A final point is that flooding in response to seismic or other failure of the dam, probably most likely at the time of highest water, would make the flood of February 1962 look like small potatoes. Since such a flood could be anticipated, we might consider a series of strategically placed motion picture cameras to document the process." By 1973, grouting in the lower part of the foundation and construction of the cut-off trench in the river channel were completed. Workers continued to lay and compact the remaining material for the dam embankment, and by November 1973, the project was finished. Once the dam was constructed, the next step was to fill the reservoir. The U.S. Bureau of Reclamation monitored the structure's and foundation's performance during this process. The reservoir was filled at a rate of 1 foot per day initially, with the bottom at around 5,500 feet in elevation. By March, the reservoir's water surface had risen to 5,167 feet, with water being released at a rate of 295 cubic feet per second through the auxiliary outlet. Due to high flow rates from the Teton River and incomplete river outlet construction, the filling rate was increased from 1 to 2 feet per day on March 23rd. From May 11th to June 5th, the average rate of increase was 3 feet per day, peaking at 4.3 feet on May 18th. Despite these adjustments, the dam's structural issues persisted, setting the stage for the catastrophic failure that would soon follow. The reservoir level continued to rise, reaching its maximum depth of 240 feet. On June 3, 1976, seepage was observed from small springs in the right abutment on the downstream side of the dam. These springs were pumping water at a rate of about 40 to 60 gallons per minute. Interestingly, the water was clear, not the typical brown color often seen when erosion carries soil and debris, which could have signaled more immediate concern. The following day, additional leaks were discovered in the right abutment, with clean water flowing at approximately 20 gallons per minute. On the morning of June 5th at 7:30 a.m., more seepage was noticed, but this time the water had a brownish color, indicating erosion. Despite this, the engineers did not initially consider it a major issue due to the previous clarity of the water. However, a wet area on the downstream face began to erode into the dam's right embankment. In response, 2 bulldozers were deployed to try to plug the leak. By 10:40 a.m., the Madison and Fremont County Sheriff's offices received an emergency call to prepare for potential flooding. Around 11 a.m., one of the bulldozers started sliding into the opening created by the seepage. The other bulldozer attempted to pull it out. Between 11 and 11:30 a.m., the project office made another call to the sheriffs, this time ordering an immediate evacuation of the area. At approximately 11:30 a.m., a large vortex appeared in the reservoir near the right side of the dam, signaling imminent danger. The 2 bulldozers on the dam began to sink into the opening, and their operators had to abandon them. Despite attempts by 2 more bulldozers to halt the vortex by dumping dirt into it, their efforts were unsuccessful. The flow through the opening increased rapidly, and by 11:55 a.m., the dam began to breach at its crest. The floodwaters continued, sweeping through a log mill and adding debris to the flow, which then battered the city of Rexburg. By 8 p.m., the reservoir had completely emptied, leaving about 2/3 of the main dam structure intact. The immediate disaster was marked by a rapid sequence of events: unexpected seepage, the failure of attempts to stop the leaks, and the ultimate catastrophic breach of the dam. The force of the water and debris unleashed by the failure wreaked havoc on the downstream communities, destroying everything in its path and forever changing the landscape of the Snake River Plain. The suddenness and scale of the disaster left little time for residents to react. underscoring the severity of the engineering failure that had occurred. Following the collapse, Reclamation Commissioner Gilbert G. Stam and the Assistant Secretary of the Interior traveled to Idaho to inspect the site. 2 inquiry panels were established, but as with most dam failures, much of the evidence was swept away during the break, so the investigation had to rely heavily on eyewitness testimony. Evacuations of the remaining sections of the dam provided some clues about the mode of failure. A subcommittee of the House of Representatives, chaired by Leo Ryan, conducted hearings and investigations that highlighted the questionable choice of the dam's location. The geology of the valley was porous and prone to permeability, increasing the likelihood of failure. According to an independent panel that reviewed the causes of the Teton Dam failure, the materials placed in the key trench and against the abutments was highly erodible. This issue was recognized by the U.S. Bureau of Reclamation early in the design process and confirmed by the panel's investigation. The porous quality and open joints of the rock at the dam site contributed to this erosion. The investigation revealed that hydrostatic pressure in the upstream jointed rock increased with the reservoir level, potentially triggering hydraulic fracturing and subsequent degradation of the main structure. Criticism also centered on the reservoir's filling rate, which was less rapid than its peak rate at 3 to 4 feet per day. Despite not all outlets being built, the Bureau's urgency to complete the project allowed for a higher fill rate, potentially exacerbating any faults that could have been identified and remedied by the project staff. The shallow foundation of the main trench and the grout curtain were criticized for being unsuitable for their intended application. Further evacuations of the dam's ruins revealed more wet areas, indicating that the measures intended to keep water out of the structure were inadequate. In summary, the Teton Dam disaster was a result of a combination of poor geological conditions, inadequate design, and a rushed construction process. The aftermath highlighted critical oversights and misjudgments that led to one of the most devastating engineering failures in U.S. history. The Teton Dam disaster highlighted the consequences of unfavorable design decisions and a lack of standard precautions. The dam's failure was a result of the engineering professionals' ability to make sound judgments under challenging circumstances. If the Bureau of Reclamation had taken a step back during construction to assess the bigger picture, rather than focusing solely on the outcome, they might have recognized the problematic situation they were creating. Unfortunately, they prioritized completing the project over ensuring its safety. The financial impact of the disaster was immense, with billions of dollars in damages. In response to the catastrophe, President Gerald Ford requested $200 million in early compensation for damages just a week after the incident, even before the official fault was assigned. Cleanup efforts began almost immediately, but the long-term consequences were severe. The dam's collapse destroyed the downstream ecology, significantly harming trout populations. To assist affected citizens, the Bureau of Reclamation established offices in Rexburg, Idaho Falls, and Blackfoot for filing financial claims with the government. By the time the claims process concluded in 1987, over 7,500 people had filed claims totaling $322 million. The Teton Dam was never rebuilt, remaining a ruin that stands as a stark reminder of the dangers of engineering failures and human negligence. Support this channel's growth by liking, commenting, and subscribing. And thank you for watching.